Hello, I'm Neeraj. Now, suppose you are an expert and going to develop an hypergraph supported multi-agent scenario for a very important SaaS application that can handle any kind of scenarios. For example, I had used this system to handle a Black Friday event related issue. So, in the development phase, you will have to answer multiple questions. Like people will ask that, okay, how your hypergraph will look like, how it will be different from the graph. Second, you may ask questions like, okay, if you develop your system, how the user will input the query, how you will collect the data for your system, how the user will get the answer for this from the system, how the background algorithm will work, and finally, code walkthrough. So let us start. As I discussed in our SaaS application, we have hundreds of microservices, multiple agents, lots of features, flags, experiments, complex infrastructure, teams, business matrices, so many things. So we will consider those things as a separate node in our things, like services, matrices, experiments, infra, regions, name, teams, business, KPIs, maybe multiple things. Hyper edges. Here hyper edges will report the real scenario, the story. Like here I'm just explaining about Black Friday. So it may be like a Black Friday EU checkout incident, but this is not like every time it will just report the incidents only. It will report like when the system is running healthy, then what are the scenarios? When the system is running smooth, system is running slow, what are the scenarios? System is working very fast, and what are the scenarios? So different modes or different things which can create a story that is recorded. Not all average thing is recorded as in hyperedges, and those hyperedges will work as a separate agent. This is different from graph-based scenarios where graph nodes act as an agent, and here we can say that okay, service A depends upon service B, feature A depends feature X depends affects the feature Y, and so on. So this is the difference. Now you will have to face another questions like from where you will collect the data. So there are a lot of areas where from where you have to collect the data like incident tickets, change logs, feature flags, monitoring alerts, business journeys, and from these our system will use a specified set of prompts. You should have the you should be very good in writing such kind of prompts so that it can automatically build hypergraph, and it will extract the informations like who is involved in each story, who is involved in each story, like services, matrices, infras, etc. And finally, for each incident, changes and journey, it will create one hyperedge, and each of those hyperedge will be an agent. So the system will dynamically create multiple agents. And if hyperedges, for example, A1, A2, A3, A4, suppose this is a hyperedge, and suppose another hyperedge having A3, B1, B2, B3, another thing is common, then there will be a link between two hyperedges. So this way it will create the hypergraph system, multi-agent hypergraph system. Now you will ask questions like, okay, suppose you develop the system, how user will input the queries? So there are multiple ways like chat interface, widget APIs. One figure also explains like how you can enter the inputs your queries. Like what will be the form of your queries? So form of your queries will be natural language or normal language text. It will be focused on what exactly you want. For example, some of the things are like Since we launched the new pricing experiment in EU, checkout has soared and payment failures spiked. What is happening and what should we do in the next 60 minutes to resolve this? You can ask this question, the system will explore and give the all responses. Again, you can ask questions like, is it safe to enable the new pricing experiment in both EU and US this weekend? What should I watch out for? Why did our EU revenue dip yesterday evening and which teams needs to act? Such kind of questions you want. You can target like the system should answer like you are working as an engineer, you are working like a management, you are working like a, some analyst. So based on your role, the system will give you the answer. Now the next thing is like what is the architecture of the such kind of system? So such system is developed in a two-phase architecture. So at the first page, which is offline page, we develop the knowledge. And here we are developing our hypergraph supported multi-agents. So first of all, we define the nodes, then report all the incidents, data structure, and then prepare the hypergraph edges. And we connect the data different kind of data sources because one story may be connected to multiple different things. For example, you have already seen that one payment failure may be linked to several engineering department and lot of policies and features. So we have to connect all those things. Only then we will be able to capture the story correctly. Another thing which is very important, like we have to normalize and map its nodes. Otherwise, it will show a lot of errors. And then finally, it generates the hyper edges. And then we prepare the hyper edge semantics, and then we store all those hyper edges as a separate agent in the some database. And after that, phase two starts. So phase two is like a question answering, like online agentic algorithm. Here we are applying. So first of all, user asks the queries, then query language understanding systems activate. It identifies that what are the different agents which are related to different stories are related to this instance, related to your questions. For example, here so many instances got activated, agents got activated. They will resolve your questions according to their understandings. And a global planner agent will get all the informations from those things. And it will generate, try to combine all informations and to create some story. And after that, a safety and critic things are very important. Otherwise, either it can damage the data or it may give the wrong results. So a safety and critic system will work. It will check all those things, finalize the answers, and finally a reporter agent will come into action and it will give you the final solution. So this is the complete scenario how hypergraph supported multi-agent system will work. So here the things are like the data it stores in a form of hypergraph edges and they how they are connected in this is very important. So this is actually working to solve the scenarios globally. So first of all, so let us go through the algorithm into more deeper. The algorithm has two phases, knowledge building and question answering online phase. So they already discussed those things. So building the hypergraph. So first part is to define the vocabulary of nodes. So for that you have to identify all the unique services and different things and which are coming under single categories or different categories. Consider them as a nodes like service nodes, infrastructure nodes, feature nodes, metric nodes, region node, team node, like that. And then under that there may be multiple nodes. So collect all those nodes, then connect to the data sources. Like if you are creating some story, then you have to understand that which are the things which are actually involved and create some stories. Like if system is running slow, system decision slow, system is hanging, system is giving means very fast results, system is just giving average speed results, having so many transactions are executing at the same time, so many stories will be there, unique stories, and for each stories there may be multiple things may be involved. You have to connect the node from all those things. This is very important, and these will combinedly create one story with your seed nodes. And after that you have to normalize the names and node id so that when you run it you will get the correct results. Now what a real story will look like one hyperedge, you already is informed, like one hyperedge means one story, and each hyperedge will be one agent, and each agent will be connected to each other like we connect hyperedges in the graph, like A1, A2, A3, sorry, A3. If these three nodes are in one hyperedge, and suppose A3, B1, B2 are nodes in another hyperedge, then there will be a connection like this. So this way, multi-agent node systems will be connected. So now let us see that what is a story looks like. So hyperedge incident INC001 type incident. Nodes are like SBC checkout, payment, metric checkout latency, metric payment error, metric revenue, infra DB, cluster A, reason EU, feature Black Friday, feature new pricing, feature team checkout, team payments, team infra, and summary is like Black Friday EU checkout slowdown with payment failures. So this is like our incident, and we repeat this process for all past incidents like INC0, 1, 2, 3, 4, and all the changes and all the key journeys, and then we create the complete hypergraph. Now how to store those hypergraph? You can easily store in graph database, document storage, file based storage. It is your choice. Now let us start like how the system will answer such questions. Suppose you have a questions like, since we launched the new pricing experiment in EU, checkout is low, payment failures increased, what is happening and what should we do in the next 60 minutes? So this query will trigger a multi-agent reasoning cascade that retrieves relevant scenarios and analyze them independently, synthesize findings, validate safety, and then produce the actionable guidance for all and in seconds. So first of all, query understanding. I already explained all those things in the actual diagram, but so suppose our query understanding sheets, how it will work. So the system generally translates the natural language query into seed nodes, specific entities in our hypergraph vocabulary. This conversation uses two-pronged approaches. First is like keyword and dictionary lookup, and second is LLM-based entity extractions. So with the help, we'll identify that which are the actual agents responsible for these things. Second is retrieve the relevant hyperedges, scenario matching and ranking. So once we examine all those hyperedges, we apply calculate the similarity like this. This course will like as intersections node E, whereas is our seed nodes and is the entities in the hypergraph. Higher scores means higher relevance. This is one of the simplest way to identify the agents, but this is not the only way. I just tried to keep the system simple and easily means reproducible. But as per your requirement, you can develop a better matching scenario. Even development of a better matching scenario can be a research problem. So suppose based on this, the system identifies, okay, incident 1 is responsible, high score. Change 003 is important. Journey EU checkout is like medium score. So select those things and C1, 3, and so three scenarios we selected for your questions. This question. Now build the scenario specialist prompt. So now again it is a game of prompt. So now here it will go to the prompt planner agent. So how the system is working. For each the selected hyperedges, we programmatically construct a specialized prompt. This prompt engineering, what it does actually, it is a systematic, repeatable template filing process that actually works for any scenario. So what is the universal scenario template? For example, you are a specialist for one of the scenarios, use the entities and users queries and explain the local hypotheses, propose local actions and give the confidence. Such kind of prompts you can write based on those scenarios. Then programmatic prompts like a hyperage ID and summary, but this is a system prompt, but this is the programmatic kind of thing that you can change. The user's original questions, hypothesis ID, group entity services, recent context. So this template driven approach generally means like we can analyze any scenario automatically without custom prompt engineering for each incident in the domain, because this is very important because we are developing a fully automated system and in the code also we have executed a similar kind of prompts. Then run the scenario specialist agents. So for each selected hyperedges, we will invoke the scenario specialist agent. These agents work in parallel. So first agent, second agent, third agent. As we already given that we have selected three agents. So analyze the Black Friday incident context, examine the pricing change details, and consider the checkout journey patterns. So in three different point of views, it will give you the solutions. So each agent returns the structured outputs like local hypothesis, like bullet points explaining what is happening. So it will give informations like that. So concrete steps relevant to these scenarios and entities and patterns, confidence levels like low, medium, high, like what is the confidence based on the for the local actions, and some orchestrations and synthesis you can do that. We invoke the LLM agent this time, like a global planner. This agent receives the all scenario specialist output, synthesize them, and give the unified intelligence kind of output. So this is the global root cause, like interactions between new pricing experiment and payment services under Black Friday EU load, generally leading to the DB connections on cluster A, causing the checkout latency and payment error. Unified action plan 1, it says that okay, temporarily disable the new pricing in EU, throttle the new critical jobs in DB cluster A, increase the auto auto cancelling of for payment service for service. Fourth is like a tighten the payment error alerts, schedule the postmortem with all team business impact. So what will be the impact? Estimated 12% conversion rate drop in EU. This kind of revenue loss per hour. Customers riskified across the declining. So the major role of global planner agent is like merge the hypothesis, unify the agents, and calculate the business impacts. So here this is the output. Now the safety and risk critic agent. What is the role of this? So before presenting the plan to the user, we add a critical validation layer. The LLM invoked as a critic to sanity check and propose the actions and identify the potential risk or conflicts. For example, identity risk, suggest the correctness, detect the conflicts, your answer should maybe conflict with each other. It also solves this problem and adds the safeguards. And finally, it provides the output. So, like if you want output for CXOs, managers, it will give you such kind of output. Technical summary for engineers, it will give such type of output. Like you depend, like type of outputs you want. So this is the important parts of the system. First page, page A, build the hypergraph, define the node types, ingest the event, normalize names, extract entities, create hyperedges. Then part B, answer questions with agentic AI, query understanding, hyperedge retrieval, scenarios specialized. You have to call the scenario specialist, global planning and safety, reporting and action. So these are the key parts of the system. Now I will go through the code. So let us go through the code. I have used the Grok free version system. For that, I have used my own API key. You can use your own API key. And here you can see that this is I have used the Llama 3.18b instant model, which is freely available for API related things. So just to develop these applications, I have used this free version. And then major part is like hypergraph, how we created the hypergraph, nodes, edges. So these are the all things are properly uh, documented. And then we describe the edges, like how we can add the edges in the hypergraph. Now the LLM clients Grok. So we are calling Grok for multiple tasks. As we are using free version of the Grok system, Grok API call, so we cannot continuously ask questions. So we have to take some sleep time, add some sleep time. So we added this also. And then Hypergraph Agentic system we had developed. How we can develop the Hypergraph Agentic system. So how we can develop the keys, how we can develop the hyperedges, different kind of synonyms. We all synonyms are defined. How we can extract the seed nodes, how we can now you can see the functions which build the entity list and then build the scenarios for each scenarios of hyperedges are actually a story and it works like an agent. All codes are properly documented, so I don't think that you will face any problem. So main pipeline when you apply for queries, then how it will work, it will just discussed in the code, discussed in the PPT. It will break the problems into seed things and then identify the. This is the related critic kind of informations, like how you can write the prompt for critics. So these are basic prompt engineering. So you can just copy it, it will work. And then technical summary, executive summary. So synthetic hypergraph, how we can develop the synthetic hypergraph. I had developed some of them because I am not using the data set. Means any ready-made data set. I am doing all those things in the code only. But instead of using that, you can directly call the informations from the data set. So that changes you can do. So here add edges. So all those things are there. So here you can see that I have added multiple edges. Then the main functions, agentic AI demo, hypergraph based. So means you can ask your questions. Then user query will be there. I can copy this query. So I have just taken some of the queries. So you can take. For example, if I ask the same query, then how the system will work. It is too big code, so it is very tough to explain each of the lines separately. So I am just directly running the code. So number of nodes are 33, number of hyper edges are 13 using backend. Now you can enter the query. So when I entered the query, it started like first stage of the query understanding. These are seed nodes they identified. Okay. Okay, so now you can see that it uses the multiple iterations so that it can get the correct information. So when I entered this question, it started understanding. Okay, these are the things. These are the scenario specialists. So it called three scenario specialists: INCBF, EU checkout, and so three scenarios it called. Then again, it generated the final answer. Then final answers like what are the immediate actions required, final answers for executive summary for senior management. So what are the immediate actions required, priority plan, communication plan, rollback plan, long-term fixes, additional recommendations. It provides all those things. And problem statement like technical summary for engineers. So what engineers should do from these errors. So it has given like investigate and mitigate the immediate issues which they have to do, retrieve the experiment design, analyze the logs and matrices, implement temporary fixes, and so all those informations are provided to like what engineers, what are the additional recommendations. So finally, after all those things, it gives the unified action plan, like what are the unified action plan and technical summaries after running, like so that it will have a minimum errors. So from this, you can easily run your system. Means you can directly use these applications with your SaaS application, and also instead of using Grok, you can use the LLM of your own choice. At the last point, I can explain that I had developed a single LLM supported hypergraph based multi agent scenario. Just for simplicity, I have used the single LLM, but you can use a multiple specialized LLMs which are specialized into different handling different tasks to develop this multi LLM supported or multi LLM expert supported hypergraph based multi-agent system for better performance. So thanks for watching. I hope you would have understand this complete tutorial.